Hello, everybody. Welcome to OSHWA's monthly show and tell stream. So this month we are really excited to have some really cool projects from 3 newly certified open source creators. You can always find our recently certified projects on Mastodon through a lovely reposting bot on our main Mastodon page, which is at OSHWA Association. So like OSHW Association. And also just a couple quick reminders. We are currently on December 19th, which means you have 3 days left to get your proposals in for the Open Source Hardware Summit that is coming up in Edinburgh in May 2025. So we're really excited. We're getting some really cool stuff in. And if you haven't submitted your proposal yet, like now is the time. We're running out of time. We want to see the cool stuff you're working on. So please, please submit and tell us all the cool projects you've been working on. So today we have 3 creators. We've got Justin Tung with the Pi T Pitmaster, Eric with Bat Tiny Guard, and Ludwig El Khoury with Sync Genie. So we're going to be looking at some really interesting projects that really show some of the diversity that exists in what a project can be and what makes something open source. So we're really stoked about that. And we're going to get started and just bring on Justin Tung right now. Hello, Justin. So Justin is the creator of the Pitmaster, Pi Pitmaster.
Yeah, I originally wanted it to have the name Pi in there in some capacity, but I think that Pitmaster is a more intuitive pronunciation. That's what I've been going with.
Yeah, I've been trying to, I'm like, I guess it's technically the pie, but it is a pit, and unfortunately we pronounce it pit, not pite. But it works. I that is a really fun part of open source projects, the naming schemes. I've noticed that we A, don't like spaces, and B, love a pun. That's pretty consistent across the board. So speaking of the Pitmaster, how did this come to be? What sparked your interest in having this exist in the world?
Yeah, so it sort of came about by me getting more and more into smoking meat, into doing, long cooks out there in the backyard over a coal and wood fire. And when you put that kind of time and investment into producing something, you want the best results possible. And a big part of that, apparently, as I learned, is to have very fine control of your temperature and a very fine control of the conditions in which you are cooking that meat. And I thought, hey, this is a very interesting opportunity to gather some data. Maybe I could just try to make my life easier by giving myself a couple more tools in order to be successful. So I initially looked into some commercially available options for smoking thermometers, and there are many out there. They tend to be expensive. They tend to be proprietary. A lot of them use the Internet of Things, and I didn't really want to connect something to my router that would maybe be, schluffing my network traffic to some random server somewhere across the world. So I thought, hey, is there some way that I could create a homegrown solution of my own? And the result is this project right here. This is the Pitmaster. I have some better photos that I can showcase in the presentation, but fundamentally, just so you can get it for scale, it's about this big. So let's see, go to share screen. Oh, sorry, I think I need to change some settings real fast.
No worries. So when it comes to smoking meat, I know very little about that. So this is generally for like we're thinking brisket scenario.
Mm-hmm. Yeah, so this works for brisket. I've used it for ribs as well. It's particularly useful for brisket because sometimes when you have a longer brisket going, and this could be 12, 16 hours, it's nice to be able to set things up for a little bit and then go and catch a nap for 30 minutes to an hour. And being able to monitor your temperatures in the interim is really helpful in doing that. It looks like my browser is telling me that I'll have to restart the browser in order to share my screen, which is a little unfortunate. But yeah, so I'm going to see if I can't save all of these as a PDF and then upload it and share it that way. But
Amazing. On the ground thinking, folks. This is what open source is all about, finding solutions to problems. Although I don't think PDFs are open source.
no,
really
they're very much not.
They really want you to pay for that, and I won't, Adobe.
Okay. So sorry, I know this doesn't make for
This is the most
very riveting
exciting part.
streamcasting.
Okay,
But
there
to
we
my
go. We've
okay.
got it.
Yeah. Yes, amazing. Yeah, so this is an image of the kind of output that I get from the pitmaster. The x-axis is time, and then the y-axis is temperature. And you can see that the two probes on the device itself are measuring two things. So the first probe, the black line is measuring the meat itself, and then the blue line is the second probe, and the blue line measures the temperature of the cooker. And this is really interesting because I kind of thought I was a rock star in terms of, how awesomely I was handling my cooker. So I very bravely put up that green patch, which is a range between 225 Fahrenheit and 275 Fahrenheit, which was my target temperature for sort of a low and slow brisket cooking, range. And I thought I would stay in there and just be rock steady in there the entire time. Turns out I am not nearly as good as I thought. But now that I have data, I can know exactly how to improve and how to, hopefully do things better next time. And I should have, let me see here. Oh, I'm trying to upload a second image of the device itself, doing this all on the fly. But yeah, from the first image, you can see from the graph that the total cook is about, I think this was over the course of about of 18 hours, 19 hours, somewhere in there, which is pretty standard for a brisket that is, I think I started with 9 pounds. And yeah, it just takes a while. And when you're making that kind of investment, it is very helpful to be able to keep an eye on things.
Definitely. I mean, everything I know about smoking meat comes from television series on cooking, because I love to watch a good Food Network series. And I know that it's a long haul process. I feel like you always see, guys talking about their like extensive processes, how they've like come to become pit masters is what I think they usually call them when they are like the top dog of the barbecue area. So this is a aptly named project, and I'm really excited about this one in the sense that like I don't have a smoker, but I feel like this makes it feel much more accessible. Like I could potentially do the thing, even though I'm intimidated by every part of smoking meat. This is a pretty great way to keep track of how that works, and especially keeping track of how the temperature is affecting the meat. That is like the whole thing. So beyond the open source aspect of it, so you started working on smoked meat, like smoked meat in general became an interest of yours in the last couple years?
I would say in the last couple of months, really.
Oh, really?
It's very fun, yeah, when my hobbies can kind of co-enable each other.
Yeah,
So
definitely.
if I was, getting interested in microcontrollers and working with a little more hardware at the time. And I was also interested in smoking meat concurrently. So yeah, everything just kind of got along. Um, I don't know if we can put up, yes, this image here. So this is kind of the guts of the device itself. It is based around a Raspberry Pi Pico W, which has an ability to create a Wi-Fi network. So I kind of use that um, to create a rogue API. And by connecting to that API with, you can use any device. I would sometimes use my phone at the beginning and found it very helpful to write another small little Python script that I could run on a Raspberry Pi. So I could sit out there with this, with the microcontroller, this Pi Pico, monitoring the temperature of the smoker itself. And then I could sit there with a single board computer and then have it ping the API. I think every couple of seconds, every 20 seconds or so, and it'll grab a data point, which is continually uploaded. So and updated from the thermometers. So that was a really easy way to gather all of the data points. I wanted to have a data collection process which wasn't very burdensome. So if I were, trying to get data every 2 seconds or so, then I would probably end up with file sizes which are much larger than useful.
Mm-hmm.
And that's something that I just felt like I didn't need. So instead, I ran it down to about 3 times a second, so a 20-second interval when I was gathering that. You can see that the Pi Pico is in the middle, and then below that in the image are the two Max 6675 thermocouple drivers, which are connected to the probes, kind of leading out of the bottom of the image. So the probes themselves are kind of insane. When I discovered these probes were a thing, because the temperature range that they cover was from like 0 degrees Celsius to 1,000 degrees Celsius, which is much higher than any cooking process for human edible, food would ever go. And they're made out of stainless steel, so I didn't have to worry about corrosion or anything else. And they also came in a variety of sizes and flexibilities and diameters and that sort of thing. So the probe that I have measuring the temperature of the cooker itself is very short and stubby, and then the one that I have measuring the meat is something longer and pointed, which I can jab into the point of the meat itself to make sure I'm taking temperatures from the middle, from the center of that, 8-9 pound hunk of meat. One thing that really surprised me was the power efficiency of using a Pi Pico. I was sort of going back and forth between an ESP32 and a Pi Pico and considering what I wanted to use to put this project together as the brains of the operation. And I'm glad I went with the Pi Pico because the energy efficiency is so high. I did a calculation with the standing power draw of the Pitmaster being about, I think it was like 7/100ths of an amp at 5 volts, and the batteries that I put in there were probably would have lasted like 2 days or something. Of course, that's a guesstimation. I've never run it that long, but it's sort of insane that I can just charge the batteries up and then go out there with it, and with a small little microcontroller have something that will last longer than my cook. And if I need to, I can charge it along the way as well. The charging board that I'm using is also something which I just found on AliExpress. You can sort of see it. It's the black square at the left-hand side, the left-hand corner of the screen. And that allows me to just plug things in with USB-C, which is very convenient because, everybody's got a USB-C that can run out to a power bank or something. And then behind that is a switch. I'm a really big fan of chunky tactile switches. So I was able to incorporate a switch, which was, it has I don't know if you can see this, but gonna do the audio. Yeah. That really does it for me. Yeah. And it also came with a sort of rubber boot that I can put over it. So with that and the gasket around the waterproof case that I'm using, and the fact that the probes themselves are connected with cable glands running out of the bottom of the case, which also have their own gaskets, the entire thing ended up being pretty waterproof as well. And this is really nice because I don't know if it's technically super waterproof, but I would gladly leave this outside in the rain and not worry
Mhm.
about it, because the probes themselves are also waterproof. The K-type probes that I'm using are that way by design, and that was a really fun feature. And it's possible because the Pi Pico doesn't really generate very much heat at all. So yeah, that's more or less the project that I threw together. And thank you so much to OSHWA for showcasing me.
Yeah, this is really fun. I love everything about this. I just think it's just such a neat way to approach something that like a lot of people don't really consider how you can like you hear so much about kitchen gadgets and it's usually just like plastic garbage that's supposed to, I don't know, cut your avocado in a nice way, but this is like such an effective way to experiment with mastering something and figuring how something works. It's really cool that you've been playing with this, and this is your first open source certified project. So, do you have anything else on the horizon? Is it also barbecue focused, or what else are you planning on working on?
Well, I have several things that I've been thinking about, and all of them are probably still a few months off, I will say. I've been thinking about, so one thing that recently crapped out on us in the theme of kitchen gadgets is a timer as well.
Mm,
We had a little, timer with a magnet that would stick to our fridge, and you'd wind it to a certain time, and it would ring once that time interval was up. But apparently, it was not long for this world, and it wasn't ringing and not doing what it should. So I thought, maybe this would be a fun chance to put together like a little electric Pomodoro situation with a rotary encoder. But I will certainly throw that up for certification as well if it ever comes to fruition.
I love that. I'm very intrigued by your desire to stay in the kitchen realm too. It's a fun area to figure out effective tools for, especially open source tools when there's so many things that go on in there that yeah, I feel like a lot of cooking is like, oh, you just know. I don't know. Like my mom and my grandma, they huge cooks, and they're always just like, oh, you just put in the right amount. You just do the right thing. So having something like this that can break it down and actually give you some kind of actual data output of like what you're actually supposed to be doing is so effective. Especially like 12 hours of cooking, creating a file that is so small still and able to like actually analyze it and go through that data is so exciting. It's a really cool project. I think we're gonna see hopefully some more people experimenting with how they can join together the love of cooking and their love of open source creating. um, yeah, really, really stoked to see what comes next. So thank you so much, Justin, for being here and telling us a little bit about the Pitmaster. Folks can find Justin online. He is JTung on GitHub, where you can see all the information about how to make this yourself. So thank you so much, Justin.
Yeah, thanks for having me.
Okay, what a rad project. Next up, we are going to welcome on the lovely Eric Rudek from ErdTech, who is, ugh, I just lost my entire train of thought, but that's okay. We're going to start fresh. um, so ErdTech is also Eric's company. So let's talk a little bit about the Bat Tiny Guard. So tell me about
Yeah.
this.
So I'm Eric, and I'm the creator of Bed Tiny Guard. Well, I've been in the electronics design and manufacturing industry, well, 7 years now professionally, and a few more as a hobbyist. And when creating electronics, I always well, most of them used uh, batteries. So there was always the problem of charging them, powering on the device, measuring currents, measuring voltages, keeping everything in check. And it was frankly a tedious task for me, for each PCB where I had those needs. I had to redesign the whole circuit. So I made the Bed Tiny Guard, which is a small module. uh, it's actually really small. So
Very small module.
it's a small module that can do all those things. So basically, it has castellated holes, so it can be dropped in any project you're working on, and you can use it basically to handle all the battery related issues that usually arise in such projects. So yeah, and I made a few devices. I made it primarily for my own use, because I make a lot of test devices, test jigs for other products we're making. So there's always that need in production, to test stuff, test batteries, test cables, devices. So I primarily made it for my own use, but I quite liked how it looked and how it performed. So that's how it ended up being open sourced and out there. Yeah.
Amazing.
So now I'd like to present my screen a bit to go through, through the GitHub of the project.
Yeah, of course.
Just a second.
Very stoked for y'all to see this a little bit more close up, because there's just the best little graphic on this guy. It's so good. And we've got Eric's screen. There we go.
Yeah, we can see that.
Yep.
All right. Yeah. So just a second to get the zoom right. Yeah. So basically, this is the mod. The demo board for the module itself. It's also open sourced. And yeah. So here's I'd call it an infographic of sorts. So it has a 12-bit ADC. It has 4 channels, so you can take accurate voltage measurements of voltage rails or anything that needs voltage measurements. Basically, it has a built-in 2-amp charger for the battery. At the moment, it's not adjustable, but the charger has protection circuits which would reduce the current if the battery which couldn't handle the full current was plugged in. And also it has a low resistance output MOSFET. It's used basically for switching the downstream circuit on and off, to actually disconnect it from the battery if let's say the battery under voltage threshold is reached, or over current threshold is reached, or something like that. So we have an under voltage protection device which triggers at, I think, 3.2 volts, which will actually shut down the module itself until the battery voltage reaches the required voltage for it to work. There's also a accurate temperature sensor on the board. This is to monitor the board temperature when charging and discharging the battery, because if you were to use like big currents, it can get pretty hot pretty fast. So the module could also shut down the system if it sensed any over temperature conditions. There's also a small 3.3 volt regulator built in, and 12-bit current sensor. The current sensor is pretty accurate. Unfortunately, I didn't quite have the time to work on the code. So the open source code is at the moment register values for most of the sensing are hard coded, and they kind of work, but I really want to work more on that part. And I also want to make the software implementation on bare metal. At the moment, it's only using Arduino, and Arduino, while it's easy to use and actually pretty great, it has a pretty big overhead, you know, performance wise, let's say. So I want to do a bare metal on the implementation on the microcontroller itself. And yeah, I think I didn't mention it all runs on the 80 tiny 1616 microcontroller. So, you know, if it is configured so it can basically go to sleep and wake up, I don't know, every few seconds, and basically it consumes very little power. So yeah, that's the features. I have a lot of documentation here, a bunch of pictures set up and stuff like that, you know, and also there's the full source available on the GitHub.
We love to see that. Documentation is key. It's always great to have very strong documentation so that people can actually reproduce things correctly.
Yeah, I actually made a detailed data sheet which covers, you know, everything about the module. So, you know, more details can be found there. It's really detailed, and you know, basically this project is kind of a exercise in doing projects the right way, how I want to do them if I had the time to do them properly.
Yeah.
So, but you know, it's still a work in progress. So I'm still looking for the perfect format and everything else.
Definitely. So this specific project is kind of your first, as far as I'm telling on the website. I could totally be wrong, but it looks like this is one of your first completed projects that are available for people to take a look at with ERDTech.
Yeah, that's right. This is actually the first open source project. Well, me and my wife opened our own company 2 years ago, and we've been working on some other, you know, like full-on commercial closed source project. So I didn't really have the time to work on something like this. But this is the first project, and it definitely won't be the last one, you know, in this format, as I actually currently am working on five similar modules. Well, basically the format is the same, but they do different things, you know, specialize in other aspects of electronics. So for instance, I'm working currently on a dual channel programmable power supply in the same format as this module. So yeah, it's still work in progress, but once it's ready and I have some more materials, it's definitely gonna get certified and be available for everyone to, you know, build themselves or just take some information from it, if nothing else.
Amazing. We love to see that. It's always great to have new open source hardware companies in the mix. We're seeing some really cool folks pop up these days. And then also, just because like I'm nosy, who came up with the little bat? He's just so perfect. I'm a huge fan of bats.
Yeah, so I'm not quite sure right now, but I think I came up with the name, but my wife did the graphic.
Well, she did a great job. It's
Yeah,
great that y'all are able to do that and like work together in such a way. To be partners in life and partners in business is always a real undertaking, and it's so great that y'all are pulling it off, and then also like making such incredible stuff. So this is launching soon on Crowd Supply, right?
Yeah, that's right. It's in the pre-launch phase on Crowd Supply. You know, we're doing the background work for it, doing some more projects. We're actually, you know, looking to get it in as much hands as possible to test it out. And well, basically, Bad Tiny series is supposed to be, or rather will be, an ecosystem for quick hardware development. So you can use those modules to do a bunch of stuff, so you have more time, you know, for actual innovations. And so you don't have to do the well, boring work. Well, it's not necessarily boring, but it gets boring when you do it like 200 or 300 times over and over again.
Yeah, the tedious work.
Yeah, exactly.
Although some of us love a little tedium, I personally can do one simple task about 1,000 times in a row before I get bored of it, which is not that useful actually in life. Most people don't. I guess I could join a factory line or something. Maybe that'll be my next gig. So when it comes to this board in particular, so was this inspired by like having to do a lot of work figuring out what was going on with your batteries, or have you been having like, what is the word I'm looking for?
Yeah. So
Other projects influencing the need for this guy?
yeah, so I was working actually on a bigger project that used, well, most of the components that are on the module, and it actually performed really well. So I put it all in as tight space as I could possibly get it, so I can reuse it, because when I was doing projects, I tried new things repeatedly. So there was like lower quality, you know, let's say Asian source chargers, which had their problems. So I found something that worked really well on most cases that well, could be applied for me. And basically I made the module inspired by that. And I'm actually, you know, I have a few different projects. So this, I don't know how well can you see it. So this one actually isn't available online because I'm still doing some work on it. But it uses the same module, and it's a battery tester. So basically, it has a bunch of resistors which are set up in a way that they draw a certain current from the battery to test it, if the battery can handle it. So, you know, so stuff like this is used daily by me, you know, for other projects, or rather products that we're doing. There's also a few demo boards that use it. You know, I made a little, so actually it's charging here. I made a breadboard, I don't know how I'd call it, adapter. So the battery is soldered here.
That's pretty nifty.
Yeah, I'm working on a lot of stuff in parallel. So there's gonna be new stuff coming out, you know, soon.
Yeah, definitely. That's very exciting. We're definitely excited to see what else comes of ErdTech and what else y'all are working on. I noticed that y'all mentioned that you do kind of a focus on STEM education. Are you kind of considering more ways that you can bring art into the STEAM area?
Yeah, well, actually, a really big project will be coming out soon, but you know, I can't talk much about it just yet. But basically, we're bringing music, which is a form of art, into STEM education in a new and innovative way that, well, I didn't see so far. So I think that's gonna be big, but unfortunately I can't talk much about it for now.
That's okay. We like teasers as well. And then yeah, I guess how can people keep up with your work?
Yeah, well, uh, my company's GitHub hosts, well, most of the stuff, well, pretty much all of the open source stuff. So that would be like the first stop, and people can visit our website, which is some general information and stuff like that. Uh, there's a lot of stuff to do, but very little time to do it. But little by little, it's going good. Yeah.
Awesome. Thank you so much for coming on today and giving us a little overview of Bat Tiny and just what y'all are up to in general. We're really looking forward to seeing what comes next.
Great. Thank you for inviting me.
All right. That was pretty rad. Again, I just really super duper extra love the graphic that would have been made by. I'm zoning out. Name Doris Rudek, who is also part of the Erdec crew. So great work coming out from there. And then now we are going to bring on our final guest of the day. We've got Ludwig here, Ludwig Elkuri, who is working on the Sync Genie.
Hey, thank you so much for having me today. I think before we talk about the Sync Genie, if you don't mind, allow me to acknowledge some people that helped developing the Sync Genie.
Absolutely.
So I'd like to thank Dr. Giacomo Scanavini, Dr. Petrus Whistler, Dr. Surin Shah, Dr. Disha Gupta, and like most importantly, Dr. Jeremy Hill. Like Dr. Hill helped developing the whole concept, the idea, but most importantly, the firmware that sits on the Genie. I'd like to share happy news with you. Also, we wrote a paper about this Sync Genie, and we heard a couple days ago that it just got accepted for publication in Hardware X. So now you can also read it in Hardware X. Let me share my screen as I talk about the Sync Genie.
Amazing. And just as a note for the folks who don't know, Hardware X is the only journal right now that accepts open source hardware. So that's pretty exciting. I think there is some work to get a couple more journals accepting open source hardware, but right now we owe it all to Hardware X. And then we have got Ludwig's presentation on the Sync Genie.
Awesome. Thank you. Okay, so it's I think before we also go to the Sync Genie, I'm gonna spend a minute or two explaining to you and the viewers also what we do in our lab and how the Sync Genie idea was developed. So like recent literature about adults with severe brain injury who were diagnosed with disorder of consciousness such as vegetative state. And when we say vegetative state, we mean you appear to be awake, but you really are not able to purposefully interact with people around you. So basically, the study measured some brain activities from a lot of patients like that, and found that 25% of these adults they reveal like very high cognitive levels, even though their motor activities were very, very impaired, right? Which is a scary number. So in our lab, we try to extract cognitive biomarkers from patients in DOC, or disorder of consciousness, and we use some brain signals, right? The sensor is EEG, electroencephalogram. You put it on your head, it measures brain activity, and we do some auditory paradigms. For example, we let these patients listen to sounds like beeps and boops, and we see how their brain reacts to these beeps and boops, and from there we can extract some information. We also run some paradigms where we run stories, right? If you like Harry Potter, let's listen to Harry Potter and let's see how your brain interact with it. And The interesting part about that is we try to correlate the meaning of the word with your brain signals, and from there you can basically extract some cognition biomarkers. So why is this whole introduction, right? Well, because as you might see here, is that when you're trying to correlate brain signals with stimuli, synchronization is very important. And in real world, maybe like 20, 30 millisecond delay is okay, but not in our application, right? In our application, things have to be very well synchronized. And this is how the Sync Genie was, the idea, that's how it was developed, basically. Now, of course, like all of us here, we're not trying to find a solution for something that fully does not exist. You can find commercial devices that do similar stuff to the Sync Genie. However, they're very expensive, and they're not programmable. They're limited to the stuff that they can offer you. So the Sync Genie is very affordable. It doesn't cost a lot of money. Of course, it's open source, so you can find the boards, the 3D print, like pretty much everything related to the Sync Genie, the codes, everything is available online. So go ahead, download it, create the Sync Genie and use it. It's over there. It can detect a stimulus, right? It can detect when a sound was presented, for example. It can generate pulses. It can generate pulses on commands. It can be used as a data acquisition system. Also, it's a cheap data acquisition system, but you can use it for some purposes. You can measure some latencies in your system, audio latency, video latency, right? It's very versatile, and we love that about the Sync Genie. So the idea behind the Sync Genie is you have a microcontroller, and you're feeding in some inputs, like you're trying to synchronize an audio, for example, and you're sending this output to your EEG cap. So you're synchronizing the stimulus that the participant is listening to or attending to with your EEG brainwave. If you look at the PCB board, it's you'll see here in the center that there's a Teensy microcontroller. So this is like a breakout board for the Teensy microcontroller. A lot of input and outputs that are used in neuroscience. The board is also available. You might need some expertise, or a tiny bit, just to solder things onto that board. But if you have some money to spare, you could always hire somebody to solder this for you, and you're good to go. The assembly of the Genie is very, very simple. You have an LCD, you slide it in the top case, you put in the board, put some screws, and there you go, you have the Genie. It's very, very simple. Few things to focus on when we're looking at the model. As you can see, there's a lot of inputs, a lot of output, a lot of different type of connectors that you can use. So if you have different devices that take different type of inputs, there you go. Now you can use it. In neuroscience, we use a lot of D-sub-25 and BNCs, so you have it there. The part that I like to focus on is this LCD display. It's actually super cool. Little old school, but it's cool with this little selector. It's a rotary encoder. We call it selector here. It's very similar to your to the volume selector in your car, for example, right? You push it in, you turn on the radio, turn off the radio, right? And then you slide it left and right. You bring the volume up and down. So this is the same concept, but you use it to interact with the firmware that you install on the Sync Genie. So if you don't have strong background in coding, that's totally fine, right? All you need to do is download the firmware that we also give with the Sync Genie onto it. And now with the selector, you can tune it to your application. You change all type of thresholds that are available in the Sync Genie. The Sync Genie can connect with a lot of devices, a lot of EEG sensors. I didn't put everything, right, because there's a lot of them. I just put two here, the SI, Flex X. These are two different EEG systems that we use in our lab. GTAC, if you're familiar with that, you can also do that. The first application and again, these are just some applications. It's not everything, right? It's unlimited. You can program it, so you can do really whatever you want with it, but just some application useful in our field, neuroscience. Like you can be listening to some music or some stories or some stimuli, auditory stimuli, but at the same time synchronizing that with your EEG. Imagine you're trying to measure the reaction time of your participant, right? So now you show maybe circles on the screen, red circles and blue circles, and you're asking the participant to hit a button or click something whenever you see a red circle, right? So now you can do that with the Sync Genie also. This is called like a nurse call. You can buy it from Amazon. It's like $20. You just plug it in. The Genie firmware knows how to work with this, and now you can measure the reaction time. For example, one type of stimuli that you might want to work with is images. You're showing images of dogs and cats, right? And you want to synchronize the onset or the time where an image appears on your screen. So what you could do is create like a little box in your screen here in the bottom left of your screen, and put it like a light detector, right? That tells that something changed in your screen. So now you know exactly where the image appeared on your screen. So there's a lot of stuff that you can do with the Sync Genie. I try to cover just a few that are important in our application, in my lab at least.
Amazing. I also really like that attention to detail on all the different applications for it, especially like I do find that frequently in the medical field, we see that updates to technology come a little bit slower sometimes. So having access to what are in every other field probably at this point considered older connectors is really important. So seeing you know, the D sub 25 output is, you know, we need those things. That comes up a lot in the medical field. I've noticed that there's kind of just so much tech there that continues to utilize these older outputs. So then within the context of your research, what kind of case studies, I don't really know what you're actually allowed to discuss because I don't really know how that works within the medical field, but what kind of case studies have you found to be effective with using the Sync Genie?
Well, yeah, I mean, as I mentioned in the very beginning, imagine you're I'm displaying, or I'm showing you some different sounds, right? Beeps and boops, right?
Yeah.
And you really want to measure when this sound actually happens, right? So how do you do that, right? I mean, you can use maybe some computer software that tells your EEG that something happened now, right? But then there's a lot of jitter. Your computer might not give you the same timing that a microcontroller can, right? So this is where the Sync Genie is working perfectly for us, where every time a sound happens and the participant actually heard a sound, this timestamp is sent directly to the EEG cap. And now you have another channel in addition to your brain signal, you have another channel called stimulus, and you know exactly where things happen. So now you can align your EEG with the audio, you can align everything. And because in my research, we look also for some latencies. And if you see certain latencies and certain magnitudes, then this tells you something. But if your latency is off, then the entire conclusion is not relevant anymore because maybe you introduced some noise in your latencies, right? So this is why devices like Sync Genies, they're very important in my research.
Yeah, definitely. So you're also specifically looking at neuroscience research. How did that become your area? What brought you to this expertise?
Oh, that's a good question. I mean, like my background was in signal processing, machine learning, and in my PhD, I was working on wearable devices, right, like your Apple Watch or similar devices. And at some point, I started getting a little fascinated with the brain. So I found like a position open in Dr. Shah's lab, and I was reading some of her work, and it was mind blowing. So I contacted her and started working with her. And then you go to the hospital or to the rehab, and you start working with I mean, we work with adults, work with pediatrics, right? But like when you work with kids, it's very rewarding, right? You go to their parents and you're sometimes able to give them some answers. So this makes you super, super happy and encourage you to continue in like working in that field. And again, the Genie is a tool that helps us provide these answers to parents.
Definitely. I mean, I can only imagine the ways that it can actually be utilized. I once in university did a study for a whopping $50, and I got to be hooked up to the EKG, the EEG, the one that goes on your head, which is what this one does. And it was really fun, actually. I found it very relaxing. They put me in like a very like low lit room, and I was responding to stimuli on a screen. So I feel like something like this probably would have made their jobs a whole lot easier.
Right. Yeah. I
And
mean, and if you ever want to come to New York City and get tested, we're always looking for like healthy control. So just let me know.
good to know. I don't know if I would fall under healthy, but um, and then do you see the Sync Genie having further iterations, or are you thinking that this makes sense where it's at and you maybe want to work on something new?
Well, the problem of being an engineer is you always find something that if you change will make your design way better. I think in its current stage, the Genie is good. I think we want a lot of people to use it. Hopefully, a lot of people to use it so they can give us some feedback, and that way we can learn more about the little things that might need to change for like revision 5 or like future revisions for the Sync Genie. But we're starting to discuss few points. So if you look at this at the presentation here, we're using like an old school LCD. It's 16 by 2 LCD display. It's very limited on the characters that it shows. There's really not a lot of stuff you can do with it. So we're thinking of maybe replacing that with like an OLED, right? So now you can put a fancier display, right? And the display will look way nicer. This has one selector, one rotary encoder, and it has two potentiometers. Potentiometers are limited in the range, right? And the rotary encoder are not. And then they have like a push button also. So we're also considering maybe adding another selector there as opposed to potentiometers. But again, this is for future designs. One thing that the Genie doesn't have is a battery, right? So you have to plug it, you have to power it. One of the reasons is that you're running an experiment and you forgot to charge it the night before, and it dies on you in the middle of the experiment. That's bad, right? So we're like, let's actually power it, but maybe putting a battery there would be very nice. And the one of the slides that I showed you in applications that involve visual stimuli, right? You see this sensor here in the bottom. This is like a photo detector. You can find it, you can buy it, right? But again, you gotta pay money to buy it, and they're usually expensive. So we're thinking of also designing like a sensor board or a tiny sensor that comes with the Sync Genie. So now you can do applications like that. So these are some ideas of like future changes. But hopefully, when more people use it, because now we use it in our lab and another lab in Albany, but we're hoping that more people start using it and it will give us some feedback and we can improve our model.
Amazing. Yeah, I mean, one of the big things in projects is always feedback is invaluable to improving and finding more ways to play with it. Have you, for the lab in Albany or within your own lab, have you seen anyone kind of do their own little changes to things yet? Or is that still kind of, no one's feels like playing with the source yet?
I'm not sure I have enough data to answer this question because the Sync Genie was deployed not a long time ago. Like we're talking maybe a couple months ago, we had the whole model used. And like, believe me, the firmware that Dr. Hill created is super nice. And it covers pretty much the majority of cases that we're working with. I think the two people who tweaked the code are me and Dr. Hill, right? Because we always have new ideas and we're always trying different things, right? Can we do TTL? Can we try serial communication, right? Like stuff like that. So we're trying to play with the code, but I'm not really sure that people are doing that simply because I'm not really sure that a lot of people have access to the Sync Genie yet. So hopefully we'll have more users and then I'll be able to answer this question way better.
Amazing. And as far as you as an individual goes, do you have any projects on the horizon that are less based in work, or are you happily sticking with neuroscience?
Well, I mean, I think for now I need to focus on neuroscience. There's a lot of questions that we hope to answer. This, I mean, it will make kids' lives way better and it will help science. But so currently, I think that will be my focus into making sure that first of all, SyncGenie is usable, people are using it, and spending more time answering scientific questions. But hopefully, in the future, maybe somebody like a user give us like an idea, and I feel the urge to drop revision 4 and then rebuild another one. So we never know.
Amazing. Thank you so much for being here, Ludwig. It was great to hear more about the SyncGenie, and we're really excited to see where the project goes, really. Like, it's come up a couple times before, but we are currently in the middle of, oh my God, what am I doing? We're currently in the middle of exploring open healthware in a much more thorough way at OSHWA, and finding more ways to have open source hardware interact with healthcare. So this is definitely a project that we'll be keeping our eyes on and seeing where that goes.
Sounds good. Well, thanks for having me.
Amazing. Okay, so what an exciting series of projects. I think we're really going to see some really cool stuff come out of these folks, and see some really cool advances in neuroscience, barbecuing, and taking care of your battery life. So thank you so much for joining us today, and for folks watching in the future, thank you for watching in the future. And just another reminder, we are still seeking your proposals for the Open Source Hardware Summit in 2025 in Edinburgh. They are due this Sunday, December 22nd by midnight, so that's not a lot of time, but also I know we all work really well under pressure in the open source community, so thank you so much for joining us, and we will see you next month on January, my calendar decided to be weird, we're going to go to a different calendar. It is going to be on January 16th. However, for the January 16th show, we will be streaming slightly earlier to accommodate some of our friends in different time zones. So we will be streaming at 11 a.m. EST, which is other things in other time zones. I will let you look it up. Catch you all next time. Bye. Okay.